Welcome back to my YouTube channel. Today we will discuss density of rational in real number. Okay, density of rational say that any given to real number there exists a rational number between them if they are distinct. Okay, if two distinct real numbers given, then there always exist a rational number between them. Okay, that means this is real line. Okay, so any two distinct real number, suppose A and B, there exists rational number between them. Okay, this property is say density of rational in real number. Okay, so how to prove this property? So let's start the proof. Suppose A and B are rational number and A less than B. Okay, so B minus A greater than 0. Okay, so by Archimedean property, there exists a natural number n such that n into B minus A greater than 1. Okay, this is called equation number 1. Okay, by Archimedean property. Now let k equal to greatest integer of n a. Okay, and m equal to k plus 1. Okay, so clearly n a less than m. Okay, how? Greatest integer of n a less than equal to n a less than equal to k plus 1. Okay, so this equal to m. Okay, this is hold. Now we claim that m less than n into b. Okay, that is graphically this is real number and point of greatest integer of n a here and n a here and in here and in b here. Okay, we claim that suppose is not m less than nb. Okay, if not m less than nb, so we have m greater than equal to nb. Okay, that is in na and nb and m here. Okay, now we show that this is a contradiction. How it is so? Now first of all, m equal to k plus 1. Okay, So we have m minus 1 equal to k. Okay, k equal to, from here, k equal to greatest integer of n dot a. Okay, so this is equal to m minus 1. Okay, so the interval, this interval, open interval, this content in this interval. So clearly open interval NA and NB or close interval, okay, any is containing close interval m minus 1 comma m. Okay, now the length of the interval m minus 1 comma m equal to m minus 1, so equal to 1. Okay, and length of the interval in a comma nb equal to nb minus na, this equal to n into b minus a. From equation 1 here, from the equation 1 we have this is greater than 1. From equation 1. Okay, so which is a contradiction. Okay, why this length of the interval is greater than length of the interval is, but this interval na comma nb containing m interval m minus 1 comma m. Okay, this is a contradiction. So we also show that by mathematically 1 equal to m minus 1, so greater than equal to nb minus na, this equal to n into b minus a. Okay, this is this interval content. Okay, this interval content, so this inequality hold. Okay, so this is also, this is from 1 we have this greater than equal to greater than 1, strictly greater than 1. So here 1 greater than 1, which is a contradiction, is a contradiction. Okay, so our claim is right here. Now numbering this equation number 2 and equation number 3. Now from equation number 2 and 3, okay, from 2 and 3 we have m less than nb, m less than nb and greater than na. So we have a less than m by n less than b. So here m and n are integers. Okay, but here n is a natural number. Okay, m is an integer and n is a natural number because m is a greatest integer function of k plus 1. Okay, k, where k kya? Where k is a greatest integer of na, this always integer value and this is integer, so product a summation of this integer also an integer, so this is a always integer and this is a natural number, so this quantity is rational. Okay, so hence the proof. Now we also show that using the density of rational in R, we can find infinitely many rational numbers between two distinct real numbers. That is, this is a real line. Okay, here my number A and here B, two distinct real numbers. Okay, so we can show that this property, using this property density, here infinitely many rational numbers. So by the density property guaranteed a rational number here. Okay, suppose here is call it R1. Okay, now this is also interval. A is a real number, R1 भी rational number, so also real number. By eigendensity property applying, we can get here also a rational number. This is R2. Okay, here. Okay, this R2 is also a real number, or A1 is also real number. So again we can find a rational number between them, R3, and continue this process. We can find infinitely many rational numbers between two distinct real numbers. Okay, this is beauty of the density property of rational in R. Okay.